AP Cram, Calculus AB, Free Response Exam Review. Question 15, Slope Field of a Differential Equation. Consider the differential equation dy dx is equivalent to 2x minus y. On the axes provided here, sketch a slope field for the given differential equation at the 6 points indicated. Okay, so I'll give you a moment to copy down these axes and the indicated points and then sketch your slope field. All right, so I'm really excited about this problem because it has a lot of cool features that are simple and you actually don't even have to know calculus or differential equations to solve it. And a lot of people might get intimidated when they hear the term differential equation, but differential equation is just a general umbrella term that means that you're looking at equations involving the derivatives of a function or derivatives. So here we have dy dx. So, and usually they have two variables that are normally x and y. It could be a and b, c and d, whatever, however you want to label your variables. So here we have a differential equation that has two variables that we're differentiating with respect to dy and dx. And a lot of you might notice that dy dx is a really neat way to say the slope or the change in y over the change in x. So that's another way that you can look at this function. Now what we're asked to do is to sketch a slope field. So that's why we're looking at this equation as being equal to our slope, okay, dy dx. And we're already given our 6 points, so most of the work is already done for us, okay? Now, we're going to start here at this point. This point is the point 0, 2. So if you were to plug 0 in here, you would get 0 minus 2, and therefore you would have a slope that looks something like -2. Okay, so there goes our -2 slope. And just note, these slopes are not drawn to scale. It's just for, identification purposes. The next slope that we're going to deal with is here. So this is the point 1, 1. If we plug 1 in here, no, 1, 2, I'm sorry, I know I said something wrong. So if we plug 1 in for x, we're going to get 2 minus 2 if we plug in 2 for y, and then our slope is equivalent to 0, which is fine. That's not undefined. It's just neither rising nor falling, okay? So we're going to have a flat horizontal slope like that. All right, and the next point, the third point we're going to deal with is right here. It's the point 0, 1. So again, if we plug in 0 for x, we get 0. If we plug in 1 for y, we get an answer of -1. So our slope should be decreasing from left to right and look something like this. The fourth point that we're going to deal with is right here. It's the point 1, 1. Now this is 1, 1. Earlier I had said 1, 1, but that was a faux pas. So if we plug in 1 for the value of x, we're going to get 2 times 1, which is equivalent to 2, minus 1, which is equivalent to 1. So our slope is going to be 1, and it should be rising from left to right, something like that. Okay, our fifth slope, I think you're getting the hang of this, it's really not that bad, is going to have the coordinates 0, -1. Again, if we plug in 0 for x, we get 0. Minus a -1, we're going to get a slope of 1, so it should be rising from left to right like so. And our final 6 point that we're going to evaluate the slope for is the point 1, -1. So if we plug in 1 for the x value, we're going to get 2 minus a -1 that's going to have a slope of 3. So it should be a little bit steeper than the other positive slopes in this slope field, and it should be rising from left to right like so. Okay? All right, so there goes your solution. this depiction right here.